as part of today's session, we are going to talk about Sitecore Docker. So let's just go over the agenda first, right? So as part of today's session, we'll be going over quick overview of Docker, where we'll be talking about what is Docker, why it is needed, benefits, and all that stuff. Then we'll also talk about the overall development flow, right, from creating image, and then setting up the solution, debugging, publishing, and things like that. Then we'll also show you how to basically set up a project specific image. Normally, when we build an image, by default we get a base image, but in case if you want to create your project specific image, how you can do that. So we will show you as part of a separate section. Then we'll also go over how to basically debug your Sitecore Docker application. Then as part of demo, we'll be talking about, we will show you how to basically we will show you some of the frequently used command which we use in Sitecore Docker, and then how to debug, how to publish, how to go over to how to basically go into a container, how to debug it, so things like that. So yeah, and then if you have any questions, feel free to ask. So before we go into more details about Sitecore Docker, let's just try to understand what is the how these Docker / containers are different than the virtual machines. So if you can see in the left hand side, we have this virtual machine. So how basically virtual machines work is, we have a host operating system, and then on top of it, we can have a number of VMs on it, and for every VM we have an independent OS on it. So with this approach, basically what happens is overall the performance, from the performance standpoint, it is not as compared to the containers, because of the fact each VM has its own set of OS there. But if you compare this VM approach with container, so in container what happens is, we have an host operating system, and then on top of it we have different containers, and each container basically relies on the kernel based on which host operating system they are into. So because there is a sharing of kernel in case of container, so which makes this application fast as compared to VM. So yeah, so benefits of the container study. So basically, when we talk about container, so basically what is container, right? Basically, let's just talk about the problem which we are facing, and then we will see why exactly we are talking about this Docker. So before Docker, we were like, all of us maybe have faced the same issues. We had a problem where let's say a team of developers is working on a specific project, and each developer they have to set up their own Sitecore instance on their local, and then for some of the time we have faced issues with some of the dependencies, right? Some version of Sitecore needs specific version of OS, specific version of SQL, and things like that, right? So from the installation perspective also, it was not very much straightforward to basically make the Sitecore base setup up and running. And then assuming the site is also up and running, sometimes we have seen issues. We say that this particular issue is working fine on my local, and developers, some of the developers say this issue is is not reproducible in his local. So there is a kind of inconsistency across environments. So basically Sitecore Docker has been brought in to basically solve all these kinds of issues. So container is something you can think of is a kind of a bundle which has an application, and whatever things are required to run that application, all the things are packaged up as part of that bundle, and that bundle you can think of as a container. So the benefit, in terms of benefit, you can see like the DevOps flow is generating high cost of infrastructure due to the overuse of resources needed by the VM. So when we talk about if you don't go for Docker, then if you have to spin up different environment, then we have to spin up different VMs, which ultimately the cost goes up. Then it is difficult for the organization to manage Sitecore infrastructure because of varying dependencies between different versions of Sitecore. As I mentioned, like we have different dependencies for different version of Sitecore to run, then wasting a lot of time on Sitecore environment. So all these kinds of problems Sitecore Docker is, containers are actually trying to solve for us. So yeah, I'll just let Himanshu to basically go over some of the basic terminologies which we should we know when when we're working with Docker. Yeah, and
thank
then
you, Ankit. Yeah, thank you, Ankit. So good afternoon, everyone. So let's try to understand some basic terms. We'll be going in detail as we progress through the slides. So let us first try to understand what is Docker file. So Docker file is nothing but a text file which contains instructions to build a Docker image. It is most likely like a batch script wherein the first line of the script will state which base image should we start from, and then it will contain instructions to install various programs, copy files, and etc. And so the end result of Docker file is you get a Docker image. So my next point is also a Docker image. So once you execute the Docker file instructions, you get the Docker image. So your next step is to push this Docker image into Docker Hub or any other registry, wherein different developers can pull in this Docker images. So once this Docker image is ready and you have pushed this to Docker Hub, for example, developer one can pull in this image and then using the compose file. So our compose file is a YAML file which is used for defining and running multi-container application. So in the compose file, we have defined different images. Ankit will be showing this as part of the demo also, but let us try to understand some basic things like we will have different images in the compose file, and we will define the different dependencies with these images. How, for example, we have a image for SQL, we have an image for CM instance. So how these images will interact with each other, all that information will be in this compose file. So once a developer has pulled in the images that were created, now he will run this YAML file, and then once you run the YAML file, execute the YAML file, you will get a container. So container we will have, for example, in our XP instance, we will have a container uh, for SQL, another container for CM instance, one more for CD. So each container is actually an instance of a Docker image. So one Docker image, one container, two Docker images, two containers, something like that. So we got the Docker file, we executed that, and we got the Docker image. Docker image we have pushed to Docker Hub or registry. Then developers have pulled in Docker images. Then they have executed the Docker compose file, and they have got the containers up. So now your Sitecore instance is actually up. Once your Sitecore instance is up, our next problem is the Docker images are actually only read only. So suppose your instance is up and then you try to create some item in Sitecore. Where does it get stored? So there the concept of volumes comes in. So volumes is a very important concept in Docker. We'll be explaining this in great detail as we progress through the slides. But for now, it is like volumes are like a writable file system. So if you create any item in Sitecore, it actually goes into these volumes. So it offers a writable file system that our containers can use. Yeah, so that those are volumes. Yeah, I think Ankit, you can go to the next slide. Yeah, Ankit, I'm done with the slide. Can you switch to the next slide?
Yeah, I have just changed the slide. You can't see
Yeah,
that?
I think it's taking some time to reflect. So, yeah, it's switching now. Yeah, so now you can see our next slide. This is about Docker installation. So you can browse this link and download the software and follow the steps to install it. So once you install, you have to make sure that you switch to Windows containers. So there are two types of containers available. One is Linux and other one is Windows. For Docker, with Sitecore, we use Windows container only. And once you have installed this, you will be able to see Docker dashboard. Ankit, can you show the Docker dashboard also?
Okay. Yeah.
So this is the dashboard that you will get once you install. Here our containers are actually running, so you can see the list here. So once you install, you will see a blank screen here. Yeah, that's it, Ankit. Ankit, over to you. Now you can proceed with next slides.
Okay. Okay. Yeah. So guys, as Himanshu explained about different terminologies, images, containers, volumes, and all that stuff. So basically, the core benefit we get with Sitecore Docker is, you basically to run your Sitecore application, whatever dependencies you have, in terms of any specific software version and all those things, you bake up all those things as part of an image, and then image will basically take it from there. You don't have to basically rely on that, if you're trying to install this particular instance in XYZ machine, whether it's going to work or not. So you don't have to worry about all that kind of stuff, because all your dependencies are already baked up and it's part of your image now. So that's the core benefit we get. So another thing is, on Docker we have a concept of, as Himanshu mentioned, about the images, and images basically works based on layers concept. So an image, image is nothing but a series of steps which basically tells how to create a container. So images are also built up using layers in using layers concept. So in this screen you can see, right, we have three different kinds of images created. The first image is Sitecore XP image, which is again based on Windows Server Core base image, which is provided by Microsoft. So if you want to build up an Sitecore XP image, which is based on Windows Server Core, so we use this as a base image, and then on top of it, we create an image for Sitecore XP. So that's how it gets accumulated, and we call it as an XP image. Similarly, if we have to build a Sitecore XP image which also has an SP on it, so again the process is also same here. The base image is something which we have to use here is Windows Server Core, and on top of it we create an image for XP, and then on top of it we do it for PowerShell. Similarly, for the extreme right, you can see we have PowerShell and SXA on it. So it has base image, then we have XP, then we have SP, and then we have SXA. So the main advantage with this layered approach here is, let's say if you're building all the three images on your local, right? So, and you can see, if you want to Google, Windows Server Core, the base size of all these different images, you will come to know it is somewhere around 9 to 10 GB for the base image. But if you're trying to build up all these three different images in your local, people think that that if you're building all these three images which has this Windows Server Core whose size is close to 10 GB, then it is going to take 10 plus 10 plus 10 30 GB space in your disk, which is not correct, because the base images are all shared, which means if the base image is first used on Sitecore XP, and when you're building your another image which also try to leverage the base image, then it will be just reused there. So it is not going to install the base image again. So that's how it happens. That's how it works based on the layers concept. So the base image will be shared across different images there. Okay, so this is a very important thing. Anyways, I'll show you on the solution also how this Docker Compose file really works. But this is very important in Sitecore Docker. So basically, Sitecore Docker is a tool you can think of, which is which we use to run multi-container applications. So in Sitecore also, if you can think of whether we go for Sitecore XP, XM, XC, or XP with SP, XP with SXA, and things like that, we have different containers created for different for different services on it. So one of the service is SQL, one of the services is SQL, Solar. Then we have XConnect, we have CMCT and all that like that. So basically, Docker Compose is a tool basically which you can use to execute a series of services which which basically end up executing your entire application. So as part of the Docker Compose file, you have your services. You can basically define different volumes on it. Anyways, we will check what this volume's all about. But basically, it's a kind of starting point you can think of once you have your images created. Once once the images are all built up in your local, and then whether you are going to pull it from some server or it is already been built as part of your local, the next step would be to go to Docker Compose, and there are different versions available for Docker Compose based on which version of which image you have used for Sitecore, because there are different images available for Sitecore XP, SXA, XP, JSS. So there are different images, and for every for different images there are different versions of Docker Compose files available, because the content varies version to version. As part of this demo, what we are going to show, we have used Sitecore XP and SXA as a base image version for us. So the compose file also has all the stuff related to that. So this is a basic structure. We have version, we have different services, and we have volumes mapping here. So that's fine. So these are the few commands, available in Docker. There are several other commands available, but normally when we work with Sitecore Docker, there are few commands which we have to use frequently. One of the command is Docker compose up, basically, which is responsible for spinning up your Sitecore application once your images are all built up. So we have a command called docker compose up, then we have another command docker compose up -d. So normally, we can use this docker compose up and -d. Basically, it starts the container in the background, and in the front end, it will just show you that your containers are all up, but in the background, it is still processing all the different containers, what is required for it to set up. Then if you want to show a list of all the containers, then you can just use docker container ls. Then if you want to see a list of all the images, you can just use image ls. If you want to inspect a specific container, you can just use docker inspect. If you want to remove an image, you can just use docker image rm and your image id. Anyways, you don't have to really worry about more on that. So yeah, so let me just show you a few things before Himanshu show you how to set up the project image. So let me take you to, let me just close this so that it doesn't get confused. Okay, so one thing which I just want to show you here is so this is the Docker compose file which I have in my local, right? So it has services. So for now, you can just ignore this part. So we have a service for SQL, and the registry source in this case is we have hosted all the images as part of our Azure Active Directory registry. So we are not pulling it from Docker Hub, so it is part of our intranet. Then we have several service for Solar. We have for Xconnect and Xconnect different versions. Then we have CD, and then we have CM, and then as part of every service we have a volume mapping, which basically tells this talks about basically data persistency. Yeah, so so when we run, so as of now, I have already executed, my Docker is already up and running. So that's what you can see, right? All my services are up and running here, but let me just, let me just go to this file system first. Yeah, source, then, and let me just, do Docker compose down. So basically what this will do is this will tear down all the active containers which are currently running. So let me just do that. Now, after executing Docker compose down, if you go to your Docker desktop, which is a user interface where you can see how many containers are actively running. So once this is done, you will see that it will show there are no active containers running here. See, it is trying to stop all the active running containers. Right, so it has started showing, and once this is all done, it will just show there are no containers running. It's taking a time now, otherwise. So it's almost over. Okay, so only SQL is left. Okay, so now you can see, we have all the all the containers are all down now, and you can see it shows like no containers running. So now how we can basically spin up our Sitecore instance. So we can just use, as I mentioned, like we have to use a command docker compose, and then we can just give up and -d. So -d is just it will still start, it will still keep processing all the things in the background, but in the front end it will just show all your containers are active. And while this is going here, if we just take a look on the Docker desktop, it will show all these containers started coming. It's still doing. So this is This is a container for Solar. This is for source monitor. This is for SQL. And it's still happening. And if you don't provide this parameter -d, then you can see, you know, all the processing things, you know, whatever it is doing in the background, it will just show everything in you know, in your PowerShell window here itself. So if you just want to avoid all that thing, that how currently I am doing it, you can just pass a filter -d. So let's just wait for a few more seconds and it should be all done. So while it, you know, it is, I think it's almost done. So this is important here, you know, and as part of volumes thing, basically, you know, we can, volumes is something which we have to use for data persistency. And in case if there is something, we are dealing with some kind of static resources and we don't want to build that static resource as part of our image. So that kind of things, you know, we can pass as part of our volume mapping. So if you see here, what we have done here is, because as soon as, you know, as soon as we tear down your containers, you know, we will lose all the data. So but next time when we come from where we actually going to get all the data, so what we can do for that, only this volume mapping has been done. So here if you see on the SQL service, we have a volume mapping, which is what this is doing. A volume mapping has been done from, you know, application data SQL folder to C data, and C data is a container location for under SQL container. So if you go to SQL container and go to the C data folder, you'll find all the MDF and LDF file. So what happens is, as we have this mapping in place, so it will basically, you know, pull down all the data from C data folder to data SQL, and then when next time when we spin up using Compose, Docker Compose up, then it is basically, you know, it will yeah, it will basically upload everything to the container, and then our site should be up. Now, so now as of now, you can see all our containers are up and running, and if we check the thing here, you know, everything is up. Now, when all our containers are up, we can, you know, just access our Sitecore by default. 1 second. Okay, so what I can do is I can just use this only, and Sitecore. I think I have already not able to switch this. Okay, this is what we have. So if I just refresh this part again, it will take some time, but while this is loading, let me just show you a few other things. So as you can see, our container is now up and running, and if you go back to our PowerShell and see what are those different images which has been created, so those images you can see with Docker image and ls. So it will basically show you all the images which has been used to spin up this instance. So it will have an image for CM first, right? So if I just maximize it, you can see we have different images, and when that all those images was created, and the image size as well. So we have all the different images. If you want to check what different containers are running currently, so for that you can use a command docker container and ls. So it will basically show you a list of all the active containers. Right, so you can see, right, we have container ID, image, based on which image this container has been created, names has been created here, Sitecore CM, Xconnect, CD, SQL, and all that. And in case if you want to go inside a specific container, then we can make use of container ID, and we can use inspect element and go inside that container in case if you want to check something there. So this is what these are the basic commands which we can use after running Docker Compose to just see a list of active images, list of active containers there. And let's just go back to see if it is still up. It is down. It takes some time initially. Let me show you. That's why I have all these things open for you, just to make sure in case if that doesn't work. So this is my CD, and if I go to so this is the default port which is allocated to our CM instance, so we can just access it by port number as well. But as the instance just spinned up, right, so it will take some time. Yeah, so I think while this is loading, Himanshu, can you just show us how to set up the project image and things like
Yeah,
that?
Ankit, can you bring back those
Yeah, sure.
PPT slides? Yeah.
Yeah. Let me know if you can see it.
Yeah.
Can you see it now?
No, we are still seeing your Chrome window.
I'm actually seeing the PowerPoint slide.
Okay, fine then, that's fine. So let me start off then. Yeah, I can see now. So this slide is about setting up project image. So let us first try to understand what is project image. For example, with Sitecore version 10, we will have images in the Sitecore registry. So developers can pull in those Sitecore images and set up their Sitecore instance. For example, developer one will pull the Sitecore image for version 10 and set up the vanilla instance. When so vanilla instance is set up, the developer can actually publish the project solution and then get the project website up. So similarly, developer two will pull in the Sitecore version 10 image, and then publish the solution specific changes to get the Sitecore instance up. As you can see here, there is redundancy here wherein each developer has to publish the Sitecore project specific solution to the vanilla Sitecore instance. So instead of doing this, what we can do is we can set up a project image where in the image itself will have both the things. You will have your vanilla instance Sitecore as well as your project specific changes. So a combination of this is known as a project image. So as part of this demo, we'll be showing you how you can create a project image. So there are two ways of creating the project image. First one is creating an image from an existing container. In this case, once you have a vanilla instance up and you publish your solution, so that container itself you can use, the running container itself you can use to create another image. In the image that you will create, you will have both the changes. You will have your vanilla instance as well as project specific changes. A second way is used to using a Docker file. In this case, you would use a file of instructions, the Docker file, to specify the base image and the changes you want to make to it. So you have the Docker file which we use to create the base image. In the Docker file itself, you can modify a few things, and once you run the Docker file itself, you will get the project image. So these are two ways we'll be showing this as part of the demo also. Next slide, Ankit. Okay, next slide is about debugging. So prior to 2019, Visual Studio 2019 with 2000, that is with the Visual Studio 2017, it was quite difficult to debug, wherein you had to inspect each Docker instance and copy the IP of the Docker instance and then attach the process while debugging to that particular IP. But with Visual Studio 2019, it's very simple, wherein you only have to select a Windows container and then select the container which you want to debug, and that's it. That's it. You're done, and then you can debug the code. I have also pasted some screenshot, but I think it'll be easier once I show the demo. Yes, Ankit.
Okay, thanks, Himanshu. So guys, just one thing which I missed. I just want to go over that piece as well. See, what we just saw here is, in this case, like those images were already present, and using those images, basically we created those containers via Docker Compose file, and we see all our containers are up in the dashboard, also Docker desktop. And if you go to the site now, just to see if it is still up or not, if it is still spinning, I think it is still spinning. It will take some time. So, but there is one more step which basically we have to do to actually create an image, right? So currently, in this case, we haven't created an image because we are using an image which is stored in our Azure registry, container registry. But the process of creating an image is straightforward. If you go to GitHub Docker images, you will find under Windows, we have Docker images, we have a build.ps1 script, and that build.ps1 script, if you open, you will find different options for creating your image, right? So you can, you have to specify your Sitecore username and your password, which you use to connect to your dev.sitecore.net. And then you also have an option that for which topology you want to create an image, right? And what is the OS version you want to use, if you want to include SP as part of your base image or not, if you want to include SXA, if you want to include JSS or not. So those are the different options you get when you try to build this PS1 script, and which typically takes some time, again depending on the bandwidth you have, and the resources you have in your system, because it has to basically download all the available resources from dev.sitecore.net. So, but yeah, once it is all done, then it is all stored in your local, and then you can just refer from there. Okay, so from the demo perspective, I'm just still waiting for this site to come up. I'm not sure why it is taking time. But normally what happens is when we spin up, right? So we have two different, because this is based on Sitecore XP and SXA, so we have two different services present as part of our compose file. So we'll have two different URLs. 44001 is that is reserved for your CM, and 44002 is reserved for your CD instance. That is part of your Docker compose file. So if I go back to my Docker compose, you can see we have service for CD, so 44002, and then we have another for CM, which is 44001. So while this is loading, but ultimately it is, once this is up,
Ankit, can you reset your IS? Can you reset your IS? I think it is stuck somewhere.
No, but if you see here, if I go to my CM, right, it will still process. It will still show. It is still processing. It is not stuck. It is still going. See. So it is still going. It will take some time, because I have seen this in many applications. Yeah. So one thing which I just want to show you here is, so once this is up, then this is what we are going to see, because we have just one plain hero slider component here, and as part of publishing, we're going to make some changes to the CSS_HTML and then publish it. That Himanshu anyways will show you. But I just want to go over the volume section. So basically, why volumes are required here. So if I go to the CM service here, right, we have different volumes. So volumes is something, it is to basically, it is used for the data persistency, plus in case if there is something which is not available as part of your base image and you want to, pass it to your active containers, you can use make use of volumes. So now you can see whatever logs file we have, which is related to your CM instance, all those logs file gets added to your data CM folder, which is part of your application. So if I go to my application folder here and then go to data, so we have different folders created for different services for CD, CM, and all that. So the log files gets added here. That's all part of the volume mapping. Then we also have a specific location. This anyways Himanshu will show you, but what we are actually trying to do here is, we have a website demo.sc folder created, which will basically push our project specific changes from this particular location to C source folder, and then and ultimately from C source folder, which is part of our container, it gets deployed to cinetpub root folder, which is part of your was directory. We also so when we talk about unicorn here, so what we are doing, we have a mapping between the source folder to C unicorn folder, right? So this source folder is part of our application, and whatever we have as part of source, it actually gets deployed to C unicorn. And this C unicorn folder is something which is again part of your active CM container, and we'll have the same path. We basically have defined the same path, same unicorn path, so that when we are running the unicorn sync, serialize and all that thing, it can actually take up everything from C unicorn folder. So if I go back to my CM, so you can see here I already showed you the SQL. So we have all the MDF, LDF created for your instance here. We have same for CD. So CD also all the logs files we have. In addition to that, I also showed you this part. So this is coming from application website demo source, so which is actually coming from your website, demo sc.sc. So whatever because this is part of our publishing profile, what we have created on the solution level, everything gets deployed here, and from here it gets pushed to C source folder, right, via this volume mapping, and then from C source folder to website folder, it is the directory which basically detects any change from C source and then push it to directory.
Guys, is it breaking for everyone or just for me?
It's breaking for me as well.
Okay.
Okay, fine. And can you allow me to share? I'll start off then from that.
Yeah, maybe because Ankit just dropped in between.
So I'll start sharing.
Hello?
Yeah.
Yeah,
Yes,
Ankit,
Ankit.
you up in between, so we weren't able to hear you. So I think Himanshu will switch for now, and then we'll come back to you. Is that okay?
Yeah, I think that's what I'm saying. Like because I'm still waiting for this instance to come up. I think Himanshu can show up the project image part and the debugging and
Yeah, that would be good.
Thank
yeah.
you.
Okay, so you're able to see my screen, right? So yeah. So let me start. So this is a solution that we have created as part for this demo. You can see we have a Helix-based solution here, wherein we have a feature, foundation, project, and website here. Under feature, we have different features for our demo website. We have hero banner, redirects, etc. And under foundation, we have foundation specific projects, and under project, we have some layouts and some 2-column layout and 3-column layout renderings, all that stuff here. So basically we have to understand how publishing actually happens. So as Ankit told you, we have, for example, the CM image, we have the path here. So once the code is published to this path, it through volume mapping, it actually goes to a location inside the Docker. So C source is inside the Docker, and this is my physical file path. So I will publish the solution to this path. Through volume mapping, it automatically goes to C source, and from C source we have a watch directory on this location attached to this path C source. So any change to this location is actually pushing data to C inet pub ww root. So I can show that here. And so this is development.ps1 file. This is actually inside the Docker. To show it as part of this demo, I have copied it to my local system. So if you see here, we are testing this path, cinet pub ww root, and then we are pushing the data. Where is that C source? Let me just search for C src c:/src. So it is, yeah. So this is where it is publishing. You can see we are checking whether the C source path exists or not. If it exists, we are copying. This is from and this is to location. So there is one watch directory file where we have this method. So from C source, we are actually copying to C inet pub ww root. So from Visual Studio, we are publishing to this location. Through volume mapping, it goes to C source, and through watch directory, it goes from C source to C inet pub ww root. Let us try to see this live. So this is my Docker instance, and this is my Sitecore instance, which is running through Docker. So let us see this hero image, for example. I'll not build the solution because, as you saw, it will take some time for instance, to get up. So let me only modify this CS.html file. Let me write demo SUG, for example, and then I will publish this. So once I publish, so you can see here, it actually goes to this path. So let us see this path here. Views, feature, I have my hero banner here, and if I see this file, you can see our changes have come here. So if I go back to the compose file, our changes are here, and through volume mapping, it would have automatically gone here. And since we have a watch directory attached to this location, it would have copied from C source to C inet pub www root. So now if I refresh my instance, it should actually come up. The text should get updated here to demo SUG. This may take somewhere around 15 to 20 seconds. But if I had built my solution, it would have taken a lot of time. Let us see the change here.
Does it affect the development time? Things being so much slower than usually on local, it's not this bad, right?
Yeah, because it depends on your machine also, right? Yeah, I think Docker requires a much higher configuration. I have 16 GB RAM, but that doesn't seem to be fine. It needs 32 GB, I believe.
16 gig usually works fine for like local development, as in if you install it the vanilla, the normal way, right?
Yeah, right. But I'm sharing my screen also, no? So that also consumes a lot of processing power.
Right.
So let's wait for 10 to 15 seconds.
Have anyone actually done development with using hosting on Docker instances and stuff like that? Have you guys worked on any project with this?
No, we have not worked on it yet. This is something we have explored. Yeah, so now it's up. We can see the changes here. Next thing what I wanted to show you is debugging. Since any development project you need to debug and check your code if it breaks anywhere. So for example, we have a hero controller here, and I've already put some breakpoints here. So let me attach process here. Attached to process with I think with Visual Studio 2019 you had to actually put in the IP of the container, but here we already have options here. So by default it is this is selected, but since we are using Windows containers, so I'll select this, and to select the container target you simply have to click on find. So once you click on find, the Visual Studio actually searches for all the containers that are running. So currently we have CM, CD, or SQL container running. So all those containers will actually pop up here, and then I can select one of the containers and click on OK. Yeah, it's querying for containers now. So to enable this remote debugging with Docker, you actually have to install the Visual Studio remote debugging tools. And also I will show you compose file, how this is actually configured, how the debugger is actually configured. Okay, let's go to the compose file first, then we'll come back here. And you can see here for debugging we have this line, this volume mapping here. So what it does is it provides a punch hole into the Docker container. You see, this is my remote debugger, Visual Studio 2019 remote debugger, and this is the path inside the container. And then we have in development.ps1. If I search for debugger, yeah, see it's written here. If you are using Visual Studio Debugger, it actually starts this processor inside the container. So this is how it maps. So we have our Visual Studio Debugger here, and then we have our container debugger here. This is how it maps. I think this should be up. You can see the list here. These are the various containers. CM instance, CD instance. I'll select CM for now. And once you select the connection target, our next step is to select the process. So you basically will get all the process list that we normally get while debugging any Sitecore instance, and then you can select W3 WP from there. So we'll wait for the processes to load.
Just one quick question regarding the debugging thing. So this is the paths which you showed regarding the debugger and all. Are those part of the default Docker Compose file and the development PS? Like, is this available in GitHub, or these you have added these?
No. This is part of the Docker images that Sitecore provides. The build.psn file. Once you run that, you will actually get this as part of the compose file itself. So this will be there in the compose file actually. Earlier, I think with Sitecore 9 it was not there. You had to add it, but with Sitecore 9.3 it is there.
Okay. But the debugger, what you can do is you can cancel and then it will pick up the container.
Sorry?
You can cancel and close it and then it will pick it up.
Yeah. It's stuck for now, I think. Yeah, it is downloading some packages, I think. It may take a minute or so. Meanwhile, what we can do is I can show. Okay, let's wait for a minute then. Yeah, it's done. I think now it will show up. Okay, let's try to understand project image till this loads. So as I told you, right, to create a project image, there are two ways. First one is using the existing container, and the second one is you modifying the Docker file itself. So I'll be showing you how to create using the existing container itself. You can see we have different containers here, one for CM, CD, and SQL, etc. So to create the Docker image from the existing container, it's very simple. First step is to stop the particular container. For that, you can run Docker stop and that particular ID. I think this is taking some time to load. I cannot stop because once I stop, then this will not work. Let me close it again. Let me try to attach the process. Okay. Find. Yeah, it works faster now. I should get the process list here. So there are two steps. First step is to stop the container, and the second step is to write Docker commit and then which container you want as an image. Just copy the container ID here and paste it here, and the new image name here. For example, P3. I will write project image 1 here. So once you execute this command, it actually creates a new image using this container itself. This is taking some time to load. Okay, fine then. I think we leave it at this. So we have to select container type and then connection target. Once you select the connection target, you will get all the processes here. Select the w3wp.exe process and click on attach. And then once you refresh the website, the debugger should automatically come in here. Yeah, Ankit, you can take now. Aninda, can you make Ankit presenter?
Yeah, sure.
Okay. So guys, for some reason, my site is still spinning up. So I don't want to wait for that. So another thing which I just want to show you is, how if let's say if you want to check something inside your container, so how you can do. So if I at this point of time, I can see from a Docker desktop board, all my containers are up and running. And in case if I want to specifically check on specific container, what I can do is the first step would be to first get the container ID. So how we can get the container ID by checking the list of all active containers first. So if I just run docker docker container ls, it will basically show a list of all the active containers. Okay, so if you can see, we have the first container is for Sitecore CM. So if I can just copy this container ID, and once I copy it, what I can do is I can just okay, sorry, yeah, docker execute, and then we have -it, then container ID, and then PowerShell. So if you want to check specifically what the file system, how the file system for container CM looks like, we can enter into PowerShell mode for CM. And if we just command ls, so this is what the structure what we are seeing. It is it is a part of Sitecore CM container, which is initpub program files and everything. This source folder, this startup folder, this tools is anyways by default part of your image, so that's how it's it is part of your container. But this src folder, this startup folder, this unicorn folder, so all these things are custom folder which has been added as part of custom volume mapping. So if we want to check how these unicorn things really work, and if I just quickly show you the unicorn part here on the Docker compose file. So on the compose file CM, we see we have a web mapping has been done from startup, to source to C unicorn, which means everything which is part of my source folder gets deployed to C unicorn inside your container. And if I go inside my C unicorn, so C unicorn and C unicorn, and if I check the list, so you can see that we have feature, foundation, project, and website. This is what it is part of our C source folder. So if I go back to Docker source and the source folder, this is what everything get copied there. And then if you want to check in, if you want to go inside and check what the YML files and anything specifically we want to check there, we can do that. So how unicorn things really happens. So as part of a solution, if you see, if I go to foundation and then serialization, everything is becoming slow now. Okay, everything serialization, then we have app config, then we have serialization base folder, right? So basically here we have defined the physical root path for our YML file, which points to source folder, and then we have Sitecore Helix layer, foundation, and the serialization path. So this source folder is again configured as part of our project. So if I go to project demo SC, I think it is app config. No, it is part of common environment. Yeah, the Docker override. So here you can see the source folder has been defined as C unicorn. So this along with the base folder, which points to layer, module, and serialization. That's how unicorn picks up all the serialization files. Now we have all the serialization files there. So how basically let's say as a developer one, I'm working on some changes, and as part of my feature development, I have added some I have made some Sitecore changes. So all those Sitecore changes gets added to my C source folder, to a specific location, let's say this hero or anything. So it gets added as part of serialization here. If I want to, if any new template has been added or any item has been added specifically for that feature hero, so it gets added here. And then because how it gets added here, because of the volume mapping, it points to C unicorn, which is part of your compose file. So it basically checks from C unicorn, it gets added to the source, and this source folder anyways we check in as part of a source control. So I added some of the templates to this feature. I check in those changes, and then developer 2, when he pulls in the changes, he gets in as part of the C source folder, all those latest YAML files, and then when he spin up using Docker Compose up, all those things goes as part of all these things goes inside to that container, the container which is running in that machine. So that's how the the unicorn changes will be on sync in the different developer machine via unicorn. Similarly, same thing is applicable for the source folder, but this is something we don't have to really check in because this is specifically for your changes. You're not going to deploy these changes as part of source control. Those view thing like views, bins, and all those things you're not going to deploy as part of your source control thing because everything is running. But this is specific to your location, so you don't have to specifically deploy these files. The thing which matters to us is the actual source, which anyways you will check in there. Now, as I showed you, like this is the way you can go inside a folder inside the container. So you have to execute a command D docker exec-it, and then you pass your container ID and PowerShell, which opens this one, and then you can wherever you want to go there you can do that. And in case it's as part of your some custom development, if you have to have some files present on your container which doesn't exist by default as part of the base image, you can do it via volume mapping. You can add it based on whichever instance you want it. If you want it as part of CM, you can have those volumes mapping defined here, like how it's being done for the existing thing. So this is how we go into this container and check the file system there. Another thing is, which I'm not sure, which I can show you, but I still want to. This is still running up. I don't think so it will happen, but because of what Himanshu showed you, like on 2019 there's a different way we can debug the Docker application, but with 2017 the way we have to debug the solution is we have to basically, let's say if you want to debug our Sitecore CM instance, so what we have to do is let me exit. Okay, and let me just again Docker container and ls. So we get a list of all active containers. Everything is slow. Okay, so we have this container which ID is this one. So I just have to take this ID. Let's say if I want to debug this one, and in case if you want to go inside SQL also, this is the same process which we have to follow. So just copy over the container ID which you want to inspect, then just do Docker inspect, and then your Docker ID, container ID, and then it gives like so many details you will see for that container. So what we are really interested in, the IP address of that particular container. So this is the IP address which we have to copy. You can just copy over this IP address, go to your solution, go to debug, and then attach to process, and then your connection type should be remote, and then you can just pass over your IP address what you have just copied from your container to your connection target and try to find it out. And then it will basically show you the list of containers which it is showing, and then select it, and then you should be good to go. But currently, as my wonderful, so there is some issue, but yeah, this is the process. We have to copy over. We have to basically run a command docker inspect, and for which container you want to inspect it. So you'll get all this information. Take the IP address from that, go to your Visual Studio, and then add it as part of. Just click on, just copy it here. Click on find, and I don't think that it is fine because it is still. Is it the same thing? 214? Yeah, I can just select this one, select it, and then you can just debug your application there. So that's how we do debugging here. So from the flow perspective, first step is you set up the project image. If you already have your image set up as part of your Azure registry, you can download it from there. Then you set up your solution, set up your Docker compose file for whichever version you want to use. Then you set up your publishing profile, that what are the changes you want to publish. In case if you have something specific on the file system, like definitely you have to have those Solar, your Solar indexes, your database, your MDF LDF, you have to keep it. But in addition to that, if you have something which you see is currently missing as part of the base image, you can set up as part of the volumes. Then you set up your publishing profile, and then it gets deployed to your C source folder, and then from there, the watch directory takes the change from C source and push it to CINIT folder. And then you just complete this process. And the unicorn step also I just showed you, like we have to set up the same way, like we just have to have an extra mapping there in the form of C volume mapping to make sure like all your unicorn changes are actually deployed to your container. So which I just showed you how we can make that happen. Last thing which I just want to show you here is some tips and tricks. Okay, let me know when you see it. So can you guys see it?
Yes, Ankit.
Okay, great. So we have to use the Windows container. So that's the first prerequisite when you're running Docker with Sitecore, with your Sitecore. So it should be Windows. Another important thing is if you want to switch between different Sitecore architecture. So this is all part of your Sitecore.com. You can if you want to just check some more details on that, you can do that. But what it says is if you're running on a specific architecture of Sitecore, let's say if you are on Sitecore XM and if you want to convert this to XP, so then you have to have clean this data script. Which is part of your solution, because as part of your solution you have CM, CD, and all those different data folders created for your specific architecture of CM with of Sitecore. So if you want to upgrade that to some other instance, then you have to basically clean up all your data folder. So which you can do by clean data.ps1 script, which is again part of your GitHub Sitecore GitHub repo. You can download it from there. You should check your system power management if you intend to work, because when you're trying to when you're building your image, you basically have to check if power management settings are all in place or not, because if it gets if something happens in between, then all your works gets lost. So that is something which you have to keep an eye. And then the last thing is disk space is becoming an issue, so you can use Docker system prone. So basically Docker system prone is something you can run after you build your project images. So because when you run your build.ps1 script, which is actually to create your images for your specific version of Sitecore, it also creates some intermediary images which is no longer required when your final image is created. So you can clean up all those different kinds, all those images via running Docker system prone command. So yeah, this is what we have. I just want to show you the debugging thing, but as the instance is not up, I cannot show you. So I'm sorry for that. Yeah. So any questions, guys? So this is Himanshu, do you have anything to share? Yeah.
No, Ankit. Yeah.
Okay, guys, any questions you
have? Just one question. The development flow for dev machines to use Docker. Is
right.
it I just wanted to get a perspective here.
Right.
When should we use it? Should we use it when our higher environments are using Docker, or should we use it as as on project need basis? So if you have QA environment or int environment which is using Docker, then not using Docker in your dev workflow, will it have any issues in your CI/CD maintenance of your higher environments? Just a perspective here.
Right. Yeah. So basically, as of now, the project which currently we are working on, so there we don't have the Docker instance up and running on the Azure level. It is just, we are using on the local development, basically for our local development. So what we do is, we let's say we have series of, we have team of developers who are actually working on it. So we just use Docker to because we have the base images, project base image already created, and then we don't want all the developers to set up their instance from scratch. So basically from what we are doing so far here is like we haven't used at least for the project which I know, like we haven't used Docker on the Azure level, which wherein like this wherein this Kubernetes also comes in place for the deployment perspective. So that is something which we haven't done, but yeah, there is a discussion going on wherein like there is we are talking about deploying all these the Docker stuff on the Azure level also, so that we can actually make use of the Azure Kubernetes part for that. But for now, how exactly it impacts the CI/CD pipeline if the Docker is used on the higher environment and not used on the on the local side. I'm not sure, but yeah, it always makes sense. If you're using the Docker on your higher environment, it always makes sense to have it as part of your local development. And in case if you're not using your Docker on your higher environment also, it again makes sense to do it as part of your local development, just to bring up some efficiency and consistency.
Okay, thank you.
Any other question, guys? Okay, so thanks guys, thanks for your time on this Monday, Saturday afternoon, and then thanks for all your time. And here are some of the references which you can check when you're working with Sitecore Docker. And I would say you just give it a try, because this is super useful in terms of at least for your local development. You don't have to basically, because down the line this is for sure that all the organizations are going to switch to Docker, because just to save some of the infrastructure cost. So this is something it's a worth try to start doing it as part of your local development. So it's a worth doing it as part of your local. And yeah, if you have any question, you can always reach out to us. And thank you.